Okay, so let's, sorry about that. I had a call coming in. I've yet to figure out how to stop that without it turning off my video. But anyway, so let's suppose I have 8 times 5 plus x. One term times 2 terms. If I have one term times 2 terms, this is the distributive property. So I'm going to take 8 times the 5 plus the 8 times the x. If I do that, 8 times 5 is 40. And then 8 times the x would just be 8x. All right, let's do it again. Negative 6 times 8 minus 2x. So I've got one term times 2 terms. To take negative 6 times 8. Now see, we're still using the same stuff we talked about. A negative times a positive. If you take a negative times a positive, you get a negative. And then a negative times a negative here is a positive. So negative 6 times 8 is negative 48. And then negative 6 times negative 2 is plus 12x. I think I know what I need to do to stop that and silence it. We'll try that. And that's the final answer there. Okay, let's do another one. Negative, parentheses, 4x minus 9. Now remember, if there's no number in front of that parentheses, understood 1. So this is negative 1 times 4x and negative 1 times negative 9. You can't combine these because they don't add together, but you can multiply that negative 1 times both of these. So negative 1 times 4 is negative 4x, and then negative 1 times that negative 9 is plus 9. Okay, 2 more examples and that will finish up section 1.4. Okay, so we've got 3 times, notice the word, 3 times 2x plus 4 plus 2 times 5 minus 8x. I would normally do what's in parentheses first, but I can't here. But I need to get rid of the grouping symbols. The way you get rid of the grouping symbols is by multiplying by what's in front of that grouping symbol. So I'm going to multiply 3 times these 2 terms. That's called the distributive property. And then 2 times these 2 terms. Well, when I take 3 times the 2x, that's 6x. And then 3 times the 4 is plus 12. And then 2 times the 5 is plus 10. You have to have a sign in front of every number. And then a positive 2 times a negative 8. A positive times a negative is a negative 16x. Now, underline my like terms. If you win 6, but you lose 16, you are down 10. Negative 10x. And then 12 plus 10 is plus 22. Or you could write it 22 minus 10x. Same thing. Okay, let's do one more to close out this section. So we've got 2 times 5 minus 3x minus 4 times 2 minus x minus negative 8 times 8 minus negative 8 minus 5x. You can't do anything in here. You can't do anything in here. You can't do anything in here. But what I can do is multiply what's in here by what's in front. So I will multiply both of these terms by 2. I will multiply both of these terms by 4. But remember, it's negative. And I'll multiply these 2 terms by a negative 1 times both of these terms. All right, so here's what, I'll say it first, then I'll uncover it. 2 times 5 would be 10. 2 times negative 3x would be minus 6x. So this is going to be 10 minus 6x. Negative 4 times a positive 2 is minus 8. And then negative 4 times negative 1 is plus 4x. Then negative 1 times negative 8 is plus 8. And negative 1 times negative 5 is plus 5x. Now I will uncover that so you can see it. Now collect my like terms. Well, I'm going to underline all of the x terms. Notice again, I underlined the signs with it. Negative 6x, plus 4x, plus 5x. So 5x plus 4x minus 6x. Now you can do this in any order. If you want to do these two together, since they're both positive, this would be 9x. But if you win 9 and then you lose 6, you are still up 3x. Now the numbers. 10 minus 8 is 2. And 2 plus 8 more would be plus 10. Or you could write that 10 plus 3x. But this is not equal to 13x in this case. Okay, this concludes section 1.4 video. And the title of this section was Simplifying Algebra Expressions. Why do we call it simplifying? Look at what we started with and look at what we ended up with. Which looks simpler? This or all of that? Well, this does. This is much simpler. But they're the same thing, they just look different. But this is a whole lot, this is in a much better form. That's why we call this the simplified version to that right there. Okay, now what we're going to do in the very next section is we're going to start basically the lifeblood of algebra and really the heart of this course. And we're going to go from expressions to algebra equations. Now, the biggest difference between an algebra expression and an algebra equation is, the visual difference is you always recognize an equation in that when you first look at it and you look at that equation, somewhere in that equation you will see an equal sign. If you see an equal sign in the original problem, that problem is called an equation. If you will notice in every problem that I've written up so far, not one single problem has had an equal sign. Now, I've put an equal sign on the page maybe when I'm going down working the problem, but there was no equal sign in the original problem. Whenever that happens, that type of problem is called an algebra equation. Now, there are different kinds of equations in algebra, and we give them different names. Just like in athletics, when we use the word ball in athletics, there's a football, a basketball, a baseball, a volleyball, a soccer ball, and the games are played differently. Well, in mathematics, there's different kinds of equations, and how you work them, what you do with them, differs depending on what kind of equation it is. And you do things to equations that you don't do to expressions. And that's where we will begin in the very next section, which is Chapter 2, Section 1, Section 2.1, Part A, Solving Equations. So that video will be coming up shortly.